Good evening, everyone, and welcome to day 5 of getting started with the basics of machine learning. So, today is the last day, and today we are dealing with the last type of machine learning, which is reinforcement learning. So, before we jump into today's session, let's take a moment to recap what we learned yesterday about unsupervised learning. Like, we learned about clustering, right? So, let's have a brief recap of what we have done yesterday. Okay, so yesterday we discussed about the second type of machine learning, which is unsupervised machine learning. And in that type of machine learning, we don't have any kind of labels. Okay, we don't have any kind of labels. It is unlabeled data. In supervised, it is labeled data. So here it is unlabeled data. And for that reason, we are using a process called clustering. In clustering, what is clustering? Clustering is like grouping similar data together. Like the similar data is like based on its characteristics, based on the features and characteristics, you group the data points together. So you can like think of it like the Lego box example I said, or the sweets example I said. Okay, so now, like, without any categories we have, we just sort them, the Lego blocks, we sorted them based on color and shape, right? So exactly like that. Yeah, exactly like that we have done. So in clustering, it's like we find hidden patterns in data where we don't know the categories like beforehand. Okay, where we don't know the categories beforehand. Also, it organizes messy data sets into meaningful groups. Okay, we organize the messy data sets into meaningful groups. Now we also saw some examples of clustering, customer segmentation. See, in customer segmentation, there might be, it can be segmented into groups like budget shoppers, or target trendy shoppers, or luxury buyers, whatever. And then the company can use this data after segmenting it. They can use it for, like, putting any offers or something. And we have movie recommendations. We have like the Netflix or YouTube or whatever, these kind of platforms use this. And yes, there we even discussed so many examples also, like we discussed about the astronomy example and all. So these are some examples of clustering. See, yeah, that's it. And now we have discussed about, like, why clustering, because it discovers the categories we didn't know before. And also it is useful, like, for so many purposes, like for in research or in some recommendation systems and all. And then we have, yeah, this is the diagram we discuss about clustering. A very simple diagram for you guys to understand. See, this is all unlabeled data, and unlabeled data, based on the clustering algorithms, they can be formed into clusters, cluster 1 and cluster 2. And when we give a new data, the based on the characteristics of these cluster 1 and cluster 2, these the new data can be grouped. Okay, so this is about like a small diagram about clustering. Then we learned about types of clustering. We learned about partitioning methods. Okay, these are like, we divide them into clusters. Like beforehand only, we have some k value, and based on that k value, we divide into clusters. We divide into groups. Like each cluster will have a centroid or like medoid at the center, and we form group around them. The points which are around them get grouped. Okay, yeah, we discussed about the student example, right, about the heights example. So see, here we have two types of, like, two algorithms, k means and k medoids. So yeah, that's what we discussed about partitioning. And then hierarchical methods, we discussed about how the tree will be formed. Here we have two types, agglomerative and divisive. In agglomerative, it's like you are going from bottom, the bottom, every individual will be treated as a group, and as they are going up, as we are going upwards, they will be merged. In divisive, it is reverse. First we'll consider all of them as a single group, and then we divide them into further groups. So it's like a, like a hierarchy, like a family tree. Then we have density based methods. So in these methods, we look at the point where there are too many points, where there is density, where the points are like, like tight, they are like tightly packed, those kind of points, they form clusters, they are dense regions, and we'll ignore those all points which are isolated. So these are the like they are the outliers. Okay, these are these are density based methods, and the isolated, like these are the density groups, and the isolated methods would be ignored, they are the outliers. And there is one algorithm that is the AB scan, and we discussed the example, right, about like food court or canteen. Okay, those kind of examples will be there. What's the surprise? You have to stay till the end. Okay, after completing today's session, after completing today's session, I will tell you what is that surprise. Okay, stay till the end. Okay, na? Okay, so the next one, fourth one, is grid based method. Okay, in grid based method, what did we discuss about? The spaces will be divided into grids. The spaces will be divided into grids, and based on that grid, clusters will be formed. Okay, and we discussed about this example, right? uh, and in a city, how there are regions, and in each region we can analyze the traffic density, and we can tell whether the area, like whether the zone is crowded or not. You can use your sting is one algorithm, you can use that for grid based methods. So these are the types of methods, like methods for a clustering. And we even discussed about the evaluation metric similarity score. So it will not give like some metric or something, but it will check how good our clustering is. Okay, how good our clustering is, like how well each point is good to the assigned cluster and not the other clusters, like compared to the other clusters. Like if the score is 1, I think you guys remember, if the similarity score is 1, then the clustering is very good. The point is in its good cluster. If it is 0, then like if it is like close to 0 or something, the cluster is between both the clusters, so it's okay. It's an okay case. But if it is like negative, it is nearer to -1, then it is absolutely in a different culture. Sorry, cluster. And so you have to change it. Okay, that's what is about Silhouette score. Then we discussed about what k-means. We discussed about k-means clustering, right? See, this is one of the popular algorithms for clustering. So here first we choose the number of clusters k, and then we randomly place these like k centroids. We initialize these centroids, right? We take randomly these values, and for each point, the other points will be assigned to its nearest centroid. The other points will be assigned to its nearest centroids, and then uh, again the centroid will be calculated now based on the values. Again the centroids will be calculated based on the values. Now there might be a little difference, right? There might be a little difference for the centroids. So now again the other points will be readjusted. Okay, the other points will be readjusted, and these steps will go on again and again. It will be repeated again and again until the centroids stop moving. Until the centroids stop moving. So this is how k-means work. Okay, and also I think we discussed about elbow method also. What is elbow method? To find the right k value, we'll do this clustering for some k values, and we'll plot the graph. And wherever you find like an elbow kind of shape in the graph, that is the elbow point, and that's where a right k value is there. Okay, so that's how you can find the right k value. And yeah, the strengths are like it's simple and fast. It is fast for larger data sets, and it's also fast when the points are very distant. Like I mean, the clusters are distant. Each cluster is distant. Okay, each cluster has its own characteristics. Okay, so it works well for those that well separated clusters. And we have some limitations also, right? That's what this is, the limitations. It's not good for all kind of data sets. And we need to know the k in advance. There will not be chance for us to always do it with elbow method to find the right k value. Like it is also sensitive to initial placements of centroids. like whatever the initial values of centroids we're taking, if we take a bad value, for suppose as I said yesterday, like if we take heights of some particular students, there might be like 150, 160, and 170. But if we take the initial point as maybe 30, 40 centimeters, then it's just going to be it's going to be worse. The clustering is going to be worse. So initial values should also be taken properly. So that is about k means, what we learned yesterday. And that is about the day 4 recap, what we learned. So till now we completed supervised learning and unsupervised learning. In supervised, we have two problems, which is classification and regression, and in unsupervised, we have clustering. So we learned about all these things, right? We learned about all these things till day 4, and today we will learn about reinforcement learning. Okay, so yeah, firstly, let us start. Okay, let us start today's session, and I want you guys all to stay till the end. Okay, I want you guys all to stay till the end, because after this session, we'll have something, a very good one. Okay, I think you're excited for that. So let us start the session for today. So are you ready for today's session? Okay, we'll start today's session. What is reinforcement learning? If you guys remember properly, we discussed about it on day 1. See, it's like an agent interacting with learns. It learns on its own by interacting with an environment. See, for like in supervised learning and in unsupervised learning also, we are giving it data. Maybe we are giving labeled data or unlabeled data. We are giving some type of data, yes or no? And it based on that data, the machine learns. But in reinforcement learning, it is very different. The agent, whatever the agent or machine, whatever it is, it learns based on, interacts with the environment, and it learns based on what, it learns, like what it had learned. See, it learns over time, like it learns over time. And is whenever it is trying to learn, it gets like something called like feedback. Okay, it's like in the form of like a reward or penalty. It will get either a reward or penalty. Reward is like positive thing, and penalty is like negative one. So based on this, like rewards or penalties, it will learn on its own. See, I think we saw this example, right? A simple example. We have an agent here. Okay, this is an agent, and this agent has two options right now: fire and water. Okay, fire and water. So the first time, the agent doesn't know what to choose. Okay, the agent doesn't know what to choose. So uh, see, for suppose if it chooses fire. Okay, for suppose it chooses fire, what happens? It might get hurt. It gets hurt. So that means it receives a penalty. Okay, it receives a penalty. Next time, the agent remembers, okay, the fire is like bad, so it avoids the fire, and instead it chooses water. Okay, so it avoids the fire, and it chooses water. So what happens now? Water might be safe for it. Water might be safe, so it gets a reward. So when it chooses a fire, it is getting penalty, and when it is choosing water, it is getting reward. Okay, so many such interactions will happen between the agent and environment, and in this way, it will learn. So the next time, what it will think? Okay, I should avoid fire, and I should choose water. So like that. That's how exactly reinforcement learning works. Like it learns from trial and error. Okay, so now see, why do we need reinforcement learning? See, we discussed about supervised learning, we discussed about unsupervised learning. So, why do we actually need reinforcement learning when we have these kind of learnings? I mean, these kind of methods. See, there not all problems, like all problems cannot be solved in the same way. Some problems are different. See, in these type of problems, it's not just about like predicting like the output. Okay, predicting the output or detecting something. some problems, we need like some sequence of decisions, okay, some sequence of decisions, and each decision affects what happens next. Yes or no? Like today, like not today, like in this time, maybe on a particular time, it does some action, and it will matter after the next time also. See, for the fire, for the agent example, when it chose fire, it learned, right, it is okay, it is bad, it is something bad. So the next time it is avoiding it, so the next time it is not wasting time on that by choosing that particular thing. So it is learning by interacting, okay. That's how reinforcement learning helps us. See, I can take this example. For example, you have here some examples playing games. Maybe for suppose you can take any kind of board games or like tic tac toe or something, or chess. See, in chess, whenever you make the first move, you cannot say whether you will win or not. You have to play till the end, okay. You cannot just make your first move and say, okay, I'm going to win or something. No, you can only find out like after some time, maybe after like some moves, maybe some 20-30 moves, you can understand after the sequence of gaming is going on, then you can understand, right? So see, one thing is, every single move you make affects your chances, like affects your chances of winning. So, like, for suppose if you move a wrong piece too early, then you might lose the game at start. And if you carefully like play, ba- carefully like play, if you play, then your chances might increase for winning. For winning, you can increase your chances of winning. So, so reinforcement learning is like that. If I move this piece, if I move this piece, what is going to happen? Will my chances of winning increase or decrease? So these kind of things it will analyze, okay. That's what is about, that's what is this example says. And also for car driving also, see, if I accelerate too much, what will happen? Should I see, for suppose maybe maybe like yellow light is there on the signal, traffic signal. So now it has to like stop or like go based on its position. If it is nearer to the signal, or if it's nearer, and if it is like safe, then it can go, right? Yellow is just wait, so it can just go. If it is very different, like if it is very if it is not nearer to the signal, and if it is, and if there are so many other vehicles also, there might be risk, right? So it has to choose the decision, like should I accelerate and go like safely, or should I risk, like, or will it be risk because of maybe like because of red light, okay. So, or should I like apply brakes and then wait, and then after that signal should I go? So because maybe I can, maybe it may cause a car crash or something. So it has to analyze those things. That's what reinforcement learning can do, because all these decisions are like connected. And if it takes one poor decision, it may lead to another poor decision also. So that's why reinforcement learning, it allows the car to learn by experience. In the same way, stock trading also, see, you can sell quickly, and you can take profit. See, sometimes we don't know what happens for tomorrow, like what the stock might increase or decrease. We have no idea at all. So we can just sell quickly and take a small profit, or we can hold the stock and like maybe, okay, it's okay, like I'll hold it. Maybe I'll get some loss now, maybe I'll gain more later, like I can get profits later. So those kind of things, it will analyze. So I this is yeah. Now, actually, this is a small brief history. I in like 1950s, there is this person like Bellman. He worked on these kind of process, like concept called MDP, which is Markov decision process. I'll tell you about this in later and further. So, like this laid the actual foundation for reinforcement learning. And after, when we fast forward to 1990s, there are so many practical applications done by like learn with the help of programs like TD Gammon. It's like a backgammon playing AI. Okay, and then in 2013 also, DeepMind, it trained an agent so to play games directly from like raw pixels or something. And then yeah, after a few years in 2016, AlphaGo, it is also an agent. It defeated the world champion, someone Lee Sedol, in the game of Go. So this was a huge, because Go is like, it is a very extremely complex game, and the AI learns in strategies by combining deep learning. It combined deep learning and reinforcement learning. With the combination of these both, so it did understood, like it did learn very complex strategies. Okay, so this is about a small brief history of reinforcement learning. Now let's have just a core idea. See, what is a core idea? It's all about the agent interacting with its environment. Okay, the agent interacting with its environment. The agent will take actions, and environment responds by, like giving a new state or like a new reward. It can be positive or negative. Okay, reward or a penalty. So the goal of the agent is to maximize total rewards over time. Okay, the goal is to maximize the total rewards over time. So it's just like, see, you can think like a dog, when it performs a right trick, it might get a treat. And if it doesn't, if it doesn't learn the trick properly, then it might not get anything. So similarly, and reinforcement learning agent also learns where it actions are, which actions are best to achieve its goal. So that's just a core idea, and I'll tell you now clearly. See, there are some key components for reinforcement learning. Okay, I see. Let's break down these each part, and we can understand. So the first one we have here is agent. So this is the like the learner, the learner or decision maker. It is the agent. It is the robo which needs to learn. Robo or like software program or whatever, like a game, any character in game also. So like just a character in game. See, in like, it's the one. It's like the main lead of all this reinforcement learning. Okay, so whatever it does, whatever actions it takes, that's what is entirely about reinforcement learning. And then we have environment. This is like everything the agent interacts with. It's like the world or like that built around this agent. So this environment gives the agent like the rewards or penalties based on the actions it take. Like you can think of the environment like the, like the world, the game. If you take the game world or something, see, there will be coins also, right? Like there will be coins, and there will be negative things like those. All these present in what? They are present in environment. Okay, so that is what is an environment is. And then we have state. So the state is like the current situation, or it's like the current situation of the agent, like what's happening right now. See, in a game like this could be like the position of the particular player, and how the, for suppose if you take chess, where the king is, where his position is, how is anybody, like is the king at risk, or like is the opposition, if the opposition did the opposition put any checkmate or something like that. Okay, those, that is what a state is. See, like that, that's the meaning of the state. And then we have action. So this is like the choice, whatever, this is the choice that agent makes. See, it can be like move to the left or move to the right, or pick an object, or like press a button or something. So like that, an action is what the agent does. Okay, the action is what the agent does. And reward is like next one we have, I think. Yeah, policy. So a policy is like, some strategies, some rules, like a rule book. It tells the agent what action to take, so in a given state. Okay, it tells the agent, okay, for suppose if you're in this particular state, maybe you can do this kind of things. For suppose in traffic lights, let us take this traffic lights case. If it is green, that means we need to go. Green means go, red means stop, and yellow means wait. Okay, So these kind of things are will be stored in policy or rule book for the agent. Okay, that is what is policy. And then we have rewards. So rewards, they tell the agent the good or bad. That's what it is. It is the feedback that is given by the environment. Positive rewards, the positive rewards are rewards, generally they give the agent the opportunity, like they encourage the agent, okay, you can do this, this is a very good one, you can do this, if you repeat this action there will be no problem at all. Those are positive rewards. Negative rewards are like opposite, okay, don't do this again, like they discourage the agent. So that's what it is, like that's what reward means. Okay. And then we have value function. See, this is a way for the agent, to like estimate how good a particular state is. It's like, the guide or map that tells the agent, like, you okay, if you are now here, your chances of getting rewards in the futures are like high, maybe like that. The value function will tell, okay, now if you are here, this is this much amount of chances are there for you to win. Or if you are in that, if you are in this position, okay, if you are in this particular position, your chances of win or your chances of getting the rewards are this much. That's how the value function will tell the agent. And then finally we have exploration versus exploitation. So exploration is like trying out new actions that the agent hasn't even tried before. They're like very new. See, for suppose you want to go to a new restaurant, you will have no idea about how the food will be there, how the prices are there, whatever. You have no idea, so you're exploring that restaurant. But exploitation is like you are used to it. The agent exploitation, the agent already knows, okay, what works well, like if I take this decision, okay, I'm going to get this reward. That is exploitation. Okay, that's what is the difference between exploration versus exploitation. Exploration means it has no idea at all, it has no idea. But exploitation, it has the idea, it knows, if I do this particular thing and this kind of reward or this kind of policy will happen, sorry, this kind of penalty will happen. Okay, that's what is exploration and exploitation. Okay, so these are the components of reinforcement learning. And I'll tell you, 1 minute. Yeah, we'll see some applications. Okay, so I think you guys understood the components. We have agent, environment, state, action, we have reward, policy, value function, and exploration versus exploitation. All these components, like they work together. Like the agent will have all these the agent will interact with the environment, it will observe the state, it will take actions based on the policies, and it will receive rewards or penalties, and it learns like that. And based on this learning, if it is taking some decision, it's like exploitation, right? It already knows everything, so it is exploitation. But if it doesn't know anything and if it is trying to learn, that is exploration. Okay, so now we have some applications. So see, in games like this, as I've said, in chess, and there are so many things like where the agents played and they even beat like best best human players. Also there are some agents who even uh, like they won over best humans also in games like chess, go, and all. So here it will learn the best rewards and it will play with, firstly it will play with the human and it will understand whatever moves they are expecting in whatever moves this agent is playing. And based on that, it will get some strategy, it will learn the best strategy and it can use that in future to win the game. Okay, and next we have robotics. Robotics, I think it's very like very easy example to say it, like it will like walk, the robots will learn how to walk. And it will learn like how to operate robotic arms. All these things come under robotics. Like, see, instead of programming every single move, like instead of saying, okay, you should move your arm like this, like with some kind of angle or something, there is no need to like program all those things. You can just use reinforcement learning, and the agent will learn on itself. Then we have then self-driving cars. See, they help. Reinforcement learning will help for all these. It is very helpful for all these autonomous vehicles, so they can make safe decisions on the road. Like the car learns, the actions like accelerating or braking, or turning left or turning right, all those kind of things. And based on this, it can learn, it can maximize the safety of traveling, and it can be efficient. And then we have recommendation systems. Okay, I think you guys are familiar with this. See, it will see what kind of movies you're watching, what kind of shows or videos you're seeing, and based on that it can learn your pattern, like how you are interacting with like with the app, like what kind of things you are watching. And based on that it can recommend. And also, yeah, in trading also, we it can see, the agent can see what, if I how to buy or like sell your assets to maximize the profit. Like it will adapt its strategy. Okay, so that's about some of the applications. Okay, now let us talk about something called MDP. Okay, MDP stands for Markov Decision Process. So it's like a mathematical way, a mathematical structure. It's like a mathematical framework, which is useful for describing a reinforcement learning problem. Okay, see, it's like just like a blueprint. Okay, it's just like a blueprint that tells how an agent interacts with its environment and makes decisions step by step. Okay, so see what here we have, here also there are some main components. We have state, actions, rewards, transition probabilities, and discount factor. I'll tell them. See, state is like, obviously I said before, it is like the current situation or position of the agent. If we are training a robot to walk, like if you're training, it will understand, okay, where I am now, what is like my position, how the robot is standing, how is it balancing, what is its speed, whatever those kind of things are state, how it is there. The actions are like, okay, now based on this the robot will be like, okay, should I move my left foot now or right foot now, should I jump, whatever. These are the actions, as I said before. And the rewards are obviously like, if the robo moves nicely, then it will not fall. If it takes a bad step, it will fall, right? It will be a penalty there. Okay, those are about rewards. And then we have transition probabilities. So this tells us how likely the agent will move from one state to another, like after taking a specific action. See, some actions are certain, like see, like for suppose, if you push, like pushing the robot's foot like a forward, it will move, right? Okay, it will move. Sometimes it might slip also. Okay, sometimes it might slip. And then we have discount factor. See, this is like a number between 0 and 1 that tells the agent how much it should take care about, like the future rewards compared to the immediate rewards. Okay, like future, not the immediate ones are like, okay, the next step, what reward it might get. The future rewards are like, okay, after maybe certain steps, after taking some certain steps. Okay, so a high value means the agent plans for like long term thing. Okay, for long term pla- for long term reward it plans for that, if the discount factor is high. If it is low, it will take the immediate rewards only. So MDP is just like the mathematical structure, okay, that tells us about how we can solve reinforcement learning problems. Now we'll understand something called as Markov property. So this is the key idea. This is the key idea behind Markov decision process. So it's like the Markov property, as I said, it says like the future, like what happens in future depending on the present state and not like on the past what happened. See, for suppose you're driving a car. I mean, the agent is driving a car, for suppose. Now, just 2 kilometers ago, it might turn left and it might turn right or something. It will the future decision, it will not depend on right now, it will depend on present state only. Now if you are here and there are only two turns, left and right turn, and there is no front way. Somewhere in a past, you just went straight. Now you can't go like that, right? On the present situation, you have only two choices, left and right. So it will not. So what Markov property says is the decisions, the actions you are taking right now, it depends upon the present state only. The past state doesn't matter like that. Okay, so that is what is Markov property. This is like really useful in reinforcement learning because it simplifies the decision making. You needn't know about all the past states, right? You just need to only look at the current state to decide what is the next action. It's like instead of remembering all that. So it's just like that. And now we'll see something called grid work. Okay, let's look at an example. So, to understand the Markov decision process better, something called grid world. So, grid world is just like a simple imaginary kind of environment which is used to teach reinforcement learning concepts. So, think of it's like just a small grid or chessboard where the agent can move from one cell to another. Okay, where the agent move from one cell to another. So each cell represents like a state, and depending on where the agent goes, it can get rewards or penalties. So it's just like how like some maze kind of thing. Okay, so some maze kind of thing where you can interact. See, so it's just like to visualize how an agent learns by taking actions and receiving feedbacks. So by practicing in this grid world, the reinforcement learning can work better in the complex situations or like the real world situations, maybe like in robotics or games or self-driving cars. So see, imagine like a small grid board you can see here, right? um, Okay, I'll tell you. So, see, in this grid board, it can move to left or to right. Okay, so the particular square is the current position. The particular square, or like it is the position, it is the state. Okay, that is the state. The square represents the state. So, wherever the agent is standing is like the current state. The agent can move up, down, left, or right based on its position. If it is in the corner, then it can only move right or down, but if it is somewhere in the middle, it can move towards all the four directions. So now reward, what happens here in the reward is, see, it can, based on the movement, based on the action it takes, it might get +1 as a reward and -1 as a reward, like the penalty. I'll show you an example. It will be very easy. I'll show you. So this is what happens. uh, See, the agent the agent's next move will depend upon its current position. That's what Markov property said, right? So now, based on these grids, we are just seeing the current state here. We're not taking care about like the other squares. Whatever square we are in, we are like taking the decisions based on that. So if you're in somewhere in the middle, you have four choices. So you can do the four choices. For suppose now currently, if you move towards some corner, you cannot be saying like, okay, in the past somewhere in the middle I had four choices, now only I have two choices. So see, that's what matters, right? You cannot take that front or down if you are in somewhere in the corner. Okay, so that's why a current state only matters. And now let's talk about q learning. So, see, don't worry if this might be a little complicated and all, but I'll tell you in a simple way. See, Q learning is like algorithm, okay? It is like a reinforcement learning algorithm. So it's called model free because it doesn't try to know everything about the environment. Like it will not learn everything about the environment. It just learns, by trial and error methods. Okay, it learns by trial and error methods. So, like figuring out what is best. That's what we are thinking, right? From the starting, we are discussing about it. Like what, see what if what decision is taken, what kind of reward will be rewarded for the agent. So that's what is generally is. So we are not remembering anything. So that's why it is model free. It's based on just trial and error. So the key idea in Q learning is like the Q value. Q, if it stands for like quality of an action. Okay, Q stands for like quality of an action in a particular state. So think of it like a score, that tells the agent, okay, how good a specific action is when it's in a certain situation. So like imagine, so suppose you're in a video game and you are like going through different stages, like different levels or something. In each level, maybe like that, you can go to left, right, or like you can stay something like that. So see some you see every choice will give you some points. Okay, every choice will give you some points, and sometimes you might gain points and sometimes you might lose points. Q learning helps the player learn like which is the best move for each level. Okay, which is the best move for each level. So after crossing all the levels, you can end the game. Okay, for each level, so that it will give you an efficient way. So how does it work? Like, see, the agent starts with no knowledge. It will not have any knowledge. It tries an action in a state. Okay, it tries to do an action in a state and sees what reward it gets, and updates the q value for that action. Okay, it will see what reward it gets and updates the q value. So over time, like this, by repeating all this trial and error, right? By repeating all these actions, it will build like something called a Q value, like a Q table of Q values. Like it's like the cheat sheet for it. So when the agent wants to make a decision, it then just picks the action with highest value, because after forming all the table based on the actions and all, it will take the highest Q value, and it will just pick that state. Okay, so see, that's what is q learning. It just learns from experience. It doesn't need a perfect model or algorithm or something. It just figures out on its own. It will do everything on its own. It will explore and update its knowledge. So in short, it's like that. Okay, so it's like for suppose when you are for suppose we can take our example only. When we start playing a game, we don't have a good idea about how the game is there, how the game is actually. But when we repeatedly play the game, we can understand it. Okay, if I move like the if I take this kind of decisions, or if I do these kind of moves, then I might win. Okay, so based on those, like how we do the how we can learn by repeatedly playing. The reinforcement learning will also learn like that from the experience. So yeah, see, that's what it is. See, q values, you can see here, q of s comma a. What it tells is like the expected total reward. See, this is the value of q. Based on this value, if the q value is high, the agent will try to take the decision. See, what is s here? S is like the state. Okay, if the agent takes action a, if while in state s, then we will represent that as q of s comma a. Okay, we'll represent that as q of s comma a. So in other words, it's like a number that predicts how good the choice will be there. That's what, right? If it is highest value, we are choosing that to get good rewards. So in that way, q of s comma a will tell us the total reward we can expect, the agent can expect. The higher the q value, the better the action. As I said before, it will take that cheat sheet, like that table of q values, and it will select the highest q value to get the better decision. The goal of q learning is to learn these q values for every possible state and action. For every possible state and action, it will calculate q values, it will make a q table, and then it will choose the action based on these q values, so that it can get this best strategy. See, once the agent knows all the q values, it can follow optimal policy. What is optimal policy? See, what is policy? As I said, because it will tell what kind of action to take based on the state, right? So now once you got all these q values, you can follow something called as the agent can follow something called as optimal policy based on the higher q values. So that's what it is here. The below one, the fourth point, like the third point, you can see here, this is what is the optimal policy. It is represented like this. Okay, with pi, it is represented with pi. You're taking the max value of q. Okay, yeah. See, there is something called as Bellman idea. What this means is the q value for doing a particular action in a state s is updated based on the immediate reward, like R. Okay, how this table is formed, is based on this Bellman idea. The values, the Q values will be updated based on the immediate rewards R and the best possible reward in the future. Okay, it can get from the state S dash. See here, you can see this Bellman idea updated rule. Okay, now like this. Okay, see, the agent keeps updating these values every time it interacts with the environment, like this. Okay, then based on this rule, the table will be updated and it can find the optimal path. So let us see this example now. Okay, let us see a maze example. See, there is some treasure with the value plus 10 and trap with minus 10, and there is some empty cells with 0. I'll show you the example. Yeah, here is that one. As you can see here, there is start, where the agent will start here. You can see the grid cell, right? And now it has to reach to the treasure. Now, first suppose if it goes down and if it then goes towards right, then what happens? It will get a trap. There, yes or no? When exploring only, it will calculate all these values. Trap means it is getting minus 10. Minus 10 is the penalty there. Okay, minus 10 is the penalty there. It is getting the trap. So it will realize that, and it will try to gain like it will try to avoid it, and it should gain the treasure, right? So based on that, it will form the Q table, and then it will go and reach the treasure. So the right path will be right. If it goes three rights, then it can reach the treasure, right? First it will explore all the possibilities, and then it will realize, okay, this is the optimal path, because it can go up also, right? It can go up, then go right, and then it can go down. There are so many other ways also where it can avoid the trap, but the best path will be going right three times. Okay, so here you can see, yeah, this is how the actions can take place. And if it is there is nothing, then that means zero. It is an empty cell, which means the agent, even after taking that action, the agent will not get any reward or penalty. Okay, so that is about this thing. Wait, I will show you these. See, the agent must balance trying new paths also. See, exploration. What is that exploration? It is trying to follow new paths. So when it is trying to balance these new paths, it should fall with, like, it should try. The agent must balance trying these new paths with the follow, like, with the best knowledge path it already has. Like, with the help of exploitation, it should use some tricks. Maybe there is something called this greedy strategy, where most of the time it chooses the best known action, but sometimes it tries something new. Okay, so and then we have yeah why yeah, why Q learning works. See, it learns directly from experience, so it doesn't need any model or environment of the environment, right? It can learn from experience. Give If it has enough trials and all, it can converge, it can form a optimal path, and it can choose the best actions. So it is the foundation for advanced methods, like this DQN and all. I think it is, they are very complex. For now, I think this is enough for Q learning. Okay, so this is about reinforcement learning, guys. Okay, and I'll tell you about this. See, in super, so this is about reinforcement learning, and see, in supervised learning, there is some data which is labeled data. In unsupervised learning, there is unlabeled data, and in reinforcement, there is no requirement of any data. The agent will learn on its own by interaction. Okay, and then here in supervised learning, the goal is to find some outcomes, which category it belongs to, or what is the continuous value that we need to predict. And in unsupervised learning also, we try to find the group, but what is the most important thing here is we will find the characteristics or patterns of that particular group. And here we need to find the best strategy, like learn the best actions and find an optimal path to gain the goal. And yeah, I have just written some analogies. Supervised learning is like, student with a teacher. See, uh, how teacher guides you and all, the teacher will tell you, like guide you, right? In the same way, in supervised learning also, there will be label data and there will be output, and based on that you can understand it. Okay, it will guide you. The data is will guide you, like the data will guide the machine, and it will then understand the patterns. But in unsupervised learning, it's like, okay, it will just explore on its own and it will find the patterns. But reinforcement learning is like, the game. It's a game. It's a simple way we can say it's like a gamer, who plays trial and error methods. They'll try all the possibilities and then they'll learn on its own. They'll learn on their own. Okay, that is what is about reinforcement learning. And yeah, these are some foundations I can just say. See, in math, like linear algebra, for machine learning, linear algebra, probability and statistics, these kind of things are important. And programming, you require Python and some, like these libraries. You need to be familiar with these libraries for basics, NumPy and Pandas and Matplotlib. Matplotlib, I think I said you in previous hands-on sessions also, like it will help for visualization and all. See, data handling and cleaning also, I said how it is important. There might be duplicate values or null values, all those kind of things. And then you see, these are some core ML algorithms for supervised and unsupervised. Yeah, so these are other things for model evaluation. See, these are for what these are for classification. I've just written few. And then there is deep learning. Deep learning is the advanced, it is a very powerful form of machine learning. See, it can, it uses neurons. It uses neural network based things, so that it can learn easily. Deep learning, and we have, yeah, some books here. You can see these. uh, if you learn basics of ML, then you can go. If you learn basics of ML, and after that, if you learn ML very well, you can go and learn about deep learning also. Deep learning is very complex actually. So so this is about day 5, guys. I think you guys are there. Do you have any doubts till now? Till now, for anything, do you have any doubts? If not, now we'll go to the interesting segment. Okay, if you have any doubts, please ask me. Okay, right? Okay, so meanwhile, fill the attendance form. I'll tell you about that. What is that interesting session? Please fill your attendance form. So I think you guys are there, right? Don't leave the session. Guys, don't leave the session. All of you who are present, scan the QR code or just go to the browser and go to slido.com and put this code there. Guys, are you there? Yeah, join. Please join. You can scan them in your phone, on your phone, or you can go to Chrome browser and then just type this code. Yeah, I can already see two people. Yeah, there are four people already. Okay. Yeah, some are joining. Yeah. Uh, Guys, don't leave, okay? Did all of you join? Did all of you join? Shall we start? Shall we start this? So, yes, okay. Yeah, just a minute, I'll start. I think all of you joined. Okay. So I'm starting the question. I think if you're not familiar, okay, okay, Rani, I'm waiting. Okay, you can. Okay, I'll wait for you. So you will. This is a quiz. Okay. You will be getting some options, and you will get 30 seconds time, and you have to select your option as fast as possible. So the quiz is about all these like about machine learning. What all I taught these 5 days. Okay. So I think we can start. Okay. So I'm starting. Okay. So you will be displayed with you. I think you got some question and options, right? Select as fast as possible. Did you guys select? Okay. So this is the option. I think all of you kept the right answer. Okay, the first we have Vishnu. Okay. Now this is the second question, guys. Which of the following is not an example of machine learning? Some of you are not answering. Some of you are not answering. Please answer. Time is running out, right? Okay. Yeah. I think somebody put this first option, which is wrong. Writing a program to find the largest number is not an example of machine learning. The others, this one is sorting emails, is classification one, and this one also recommending movies, and then stock price prediction, it is a regression example. Okay, don't get confused. Okay, we have Pujita and Aparna at the start. Okay, the next one. Which of the following is a type of machine learning? Yeah, two members did not answer this. Come on, guys. Yes, it's all of the above. Okay, again we have Pujita and Aparna, and we have Tanmay also. Okay, the next question. Okay, yes, it is unlabeled data. Okay, some of you guys are very fast in answering. Actually, next one. Feature in ML is. Okay, I think you might have been confused a little. Uh, it's input variable. I think some of you guys are confused. Feature, we are giving that feature, right? When you take classification and all, the output will be the class, or output will be the continuous value, or output will be some kind of cluster or something. It will not be the feature. Depending upon the feature, we are trying to find patterns, and based on the patterns, we are doing this thing. Okay, we are predicting the output or classifying or doing something. Okay, so don't get confused there. This is the next question. Okay, there are two more people. Answer fast. Some of you are not answering at all. I don't know why. Oh, somebody. It's not false. It's not false. Okay. It's see they learn, right. The machine, they learn. Okay. Based on the patterns and features, based on the data, also they try to improve. Okay. We have Pujita and Tanmaya. Next question. Which algorithm is used for classification? So don't get confused. Read the question properly and then answer. I don't know why some of you are not answering here. Okay. See, don't get confused. The one we learned is KNN in classification. It is K nearest neighbors. K is for clustering. And linear regression only. It is regression. Logistic regression is classification algorithm. Linear regression is regression. Okay. And yeah, K means is used for clustering. Which algorithm is used for regression? This is very easy one. At least don't get confused for this one, guys. Oh, somebody got confused again. K means is for clustering. Okay, K means is for clustering. Linear regression. It's linear regression. Here in linear regression, I think you guys remember, right, about the relation. Yeah, next one. What is overfitting? We discussed about this also. In on day two, we discussed about overfitting. Yes, model performs well on training data but poorly on new data. That is what is overfitting. Okay. Next question. K means is used for. K means is used for. Okay, so it's not classification, it's clustering. I just said right. I have just said right now. Again, why did you guys got confused? It's not classification, it is clustering. K means is for clustering. KNN is for classification. Okay. Next, which metric is used for regression? Okay. It's not F1 score, it is mean squared error. The leaderboard is not changing, the same people are there. The next one, which of the following is an example of clustering? Okay, next one. Which metric is used for classification? Precision, yes. Mean absolute error, that is used in regression, guys. That is used in regression. Precision is used for classification. Next one. I'm seeing some of you guys are not answering some questions. Don't leave, okay? Try to put some answer. Try to select some choice. Okay, I expected this. I expected this one. Multi-class classification. What is multi-class classification? Do you guys remember? Do you guys remember what is multi-class classification? Please answering. See, in multi-class classification, um, that is different and multi-label is different, right? Multi-class classification is different and multi-label is different. In multi-class, there are more than two classes. Okay, there are more than two classes, but they belong to only one class. A particular data point is belong to only one class. Okay. I don't know who did the mistake. The leaderboard changed. We have Shreya. Okay. Which of the following is not a real type of clustering? Again, some people got confused. I asked which of the following is not a real type of clustering. Multi-class clustering, there is no type of clustering named multi-class clustering. See, okay, multi-class, we don't know the classes right before clustering. We don't know what classes they are. Yes or no? So how can, like, it's not there. Multi-class clustering itself, there is it is not a real type even. Okay, multi-class clustering is not even there. Next one. Guys, time, time is up. Answer fast. Wait, so many of you got confused. I already said this example on what, day four? I think so. When day three, I said about this example on day three, right? See, what is linear regression? Linear regression, the relations are linear. They are either increasing or decreasing. And in multilinear, see, in linear, it depends upon only one characteristic, or like one kind of feature. Okay, but in multilinear, it might depend upon multiple features. Okay, like multiple characteristics, like that. So in multilinear also, the relation is linear, right? The relation is linear, either it is increasing or decreasing. But if you see this question carefully, the temperature is low in the morning, high in afternoon, and low again. So it is in non-linear regression, right? It is a non-linear relationship. So it is polynomial regression. Okay. Okay. Oh, it changed. Leaderboard got changed. I think all those people who kept the wrong option did not attend the class. Maybe. What is the main goal of reinforcement learning? Yes, all of you said the correct option. Okay, the next one. There are three more questions, guys. Come on, the rest of the people also. Okay, some of you kept some other answers. We'll see. See, I did you listen to today's class? Have you listened to today's class? Because I said what is an agent? It is, you can simply think it is a robo or it is a learner. Okay, so yeah, that's what it is. Come on, the other people also. In reinforcement learning, the reward can be both positive and negative. It's true or false? False. Why did somebody choose false? Ayo. Okay, next one. The last question, guys. Okay. See, the correct option is option one, and yeah, we have three. We all these people. We have top five: Tanmaya and Pujita and Aparna, Chaitra and Shreya. Congratulations to all these people. Okay, so the surprise is we want to give you some gifts for the top people. We want to give away a few gifts to the top three people. So we want all the top three people to mail us your name and you have a mail, right? I'll put it in the chat box. Mail your full name and okay, write, put the mail, your phone number also, okay, your full name and your phone number also, all the top three people. Okay, but others also, they did very great. We are very thankful for you all for joining this session, for joining the boot camp. You guys, thank you for all of you for joining all the 5 days. And I think you guys had basic clarity on what are the basics of machine learning. Okay, what are the basics of machine learning? And if you have any doubts, you can still mail us to Nexus Farm. You can ask your doubts. We'll clarify them. Hope this bootcamp got useful to you. If you want to share anything, you can comment something. So congratulations to everyone. You successfully completed this boot camp. Uh, we'll be providing the certificates also to the active learners. Okay, the ones who attended the sessions. We will be providing the certificates also. So don't worry at all. All of you played really well. Okay, don't. I think. Thank you. Okay. Yeah. Thank you. Which type of machine learning is better? See, I mean, it depends upon the problem. Okay, it depends upon the problem. It depends upon what input you have, like what I mean, what data you have. It depends upon that which type of machine learning to choose. Firstly, as I said in the workflow, the very first step there only you have to decide. Okay, uh, see, like exactly at the problem based on the statement. For suppose if you are taking spam detection, spam email classification, there you need classification because you're categorizing it based on the input you're giving, based on what output you're expecting. That kind of model you have to select, that kind of thing, like learning, that kind of machine learning you have to select. So there is nothing like a better machine learning or something. See, these problems also have their own models, own algorithms. So it all depends upon your problem, what you want to do, like what your goal is to. Okay. What about for top 10 members, ma'am? See, actually, there are only very few people. So, see, Vishnu, you really did great. I don't know your score, but all of you did really great because all of you learned a lot of information in 5 days. Just 5 days, you learned a lot of information. We'll be providing certificates to all of you guys. Okay, we'll be providing certificates to all of you guys. Okay, and for learning this, and I think you guys really did great because learning machine learning in 5 days is actually not possible. I've just introduced you all basics, but still in quiz, on quiz, see, one of you got even 20 on 20, and there are people like even with 19 and 18 scores. You guys really did very well. So keep keep learning with this enthusiasm. Also, we act not just machine learning, we will even do more boot camps in our future, not just about machine learning. We'll explore more domains. So keep tuning to Nexus Swarm. You will get so many updates also. Okay, not just this. Okay, Vishnu, you can participate in many other things also. So stay tuned to Nexus Swarm. Okay. uh, Still anybody want to say something? You can share. Yes, guys, subscribe to our channel and also follow us on Instagram, and both on Instagram and LinkedIn. We'll be providing more such boot camps, more such knowledge exchanging sessions also. There'll be so many sessions also. We okay. uh, Please try to actively participate in these sessions also. Yeah, thank you. Great bootcamp. Thank you so much, Poochta. So that's it for this bootcamp, guys. I'm really glad to be hosting this bootcamp and teaching you all. Thank you so much for your active participation also. So that's it, guys. Thank you so much and take care.